Yeah, so I just wanted to get on and talk about water.
Okay.
It's good.
So, as we both know, 70% of the Earth's surface is covered by water. Where do
Mhm.
you think it came from?
Like, why does Earth have any water at all? We find a tiny bit of water in meteorites and stuff like that, and where we have a pretty good idea that that's what forms planets. Well, planets like ours, at least.
So, basically, you believe that all the Earth's water essentially came from comets or asteroids?
Mostly asteroids, because those are more common. But yeah, I mean, yeah, water makes up 71% of the surface, but all of the water on Earth actually doesn't amount to all that much. So even a really small fraction of whatever water is in like an asteroid or a meteorite, if you scale it up to the size of planet Earth, you do get around that much, or you can get that much water. But even like, I mean, like, there are several moons in the solar system that have more water than all of Earth does, despite them being uh, way smaller than Earth.
So, I mean, I've just run only a few numbers here. So, what I'm able to find is saying that there's like 126 quintillion gallons of water. And I know that essentially 1 gallon weighs something like 8 pounds. And to the best of my knowledge, the largest, I mean, like comet, ever discovered is like only 500 trillion tons. So, I'd be wondering at what degree, how much, like when, how exactly would that come about? Like, do you know anything about that? I mean, that's pretty much actually the extent of what I know. But any
So,
ideas
I
about
mean,
that?
not really, but also I'm not really saying that this is necessarily the answer, but like we do know that there's water inside of meteors and asteroids, and comets have a lot more water. But even just the small amount of water that's in meteors and asteroids, that could be enough water to make a planet like Earth in it. But there are, I'm not going to be able
But
to.
based on what estimates, though, based on like what facts? Because like I just said, the largest comet that I'm ever aware of is something like 500 trillion tons. And I mean, if we're
So,
talking about 326 quintillion gallons times 8 pounds each, I
right.
mean, what type of model could possibly account for that much water on the surface?
I mean,
So,
it's going to be
like,
multiple impacts, not just one, and there could be more
yeah,
to it, but it's happening over a very long course of time, right? More and more is added.
the way you're saying it is like Earth was basically fully formed, and then a bunch of water rich comets or something crashed into the Earth and delivered its water. That's not what I'm saying. I'm saying a bunch of asteroids, mostly asteroids that have a tiny amount of water in them, countless numbers of them collided together to form the Earth, and then the Earth would have been molten, so the water evaporates to the surface, and then that's what forms the like surface waters that we have. We're pretty sure there's huge amounts of water still trapped in the mantle too, like way more water that's on than is on the surface of the Earth.
Yeah, so that was going to be actually my second point bringing up, but I'm definitely aware that, in this model that, as long as there was an atmosphere, they assumed that there was water, right? So that's, how old is the Earth? Like they say, what, 4 to 6 billion years old? And so water would have been present, at that whole time.
Mm-hmm.
So, I'm not sure exactly how you divide that up, if that's like, 75 quintillion gallons every billion years or something. But I would just literally like to actually see a model that fleshes out how many comets, how big would they have to be, how would they, come in contact with the Earth to actually form it how they do. But you also bring up a great point that technically most of the Earth's water is under the crust of the Earth, right? Not even on the surface.
Yeah,
So
we
then I'd
think so.
further like to see how in an evolutionary model you get, more than the water on the surface trapped under the surface. I'd really like to see how
Oh,
that
you
happens.
moron! I'm not talking about you. I'm watching a basketball game. That was the dumbest play I've ever seen. Sorry. um, well, so there are I don't want to say this. There are certain like crystals that have water as part of the crystal structure. So if you Google like water of hydration or oh, that's the best. I don't know what else to call it, but so you can get like these. It's really common with simple chemicals like copper sulfate and stuff like that. But we know that I think gypsum maybe has a lot of this. I think gypsum has a lot of water in it, but there's water in
Gypsum, is
it.
that a
But
moon or something? I'm unfamiliar with that.
gypsum is just a it's just a mineral. It's what drywall is
Oh,
mostly made of and cement.
oh, okay.
So it has a lot of water in it, but it's not like it's a coconut with water in it or a geode with water in it. Water atoms or water molecules are literally part of like the crystal lattice structure of it, right? So what can happen is that's in there. So if that rock gets melted or molten, then the water can separate from it. And you can, I mean, you can do. I've done that. I actually did that in my classroom the other day. I was showing my students. Just take some common mineral or whatever that we use for experiments. If you put it in a Pyrex tube and hold it over a flame, the water comes out of it, and the dry stuff just stays behind. So water can escape to the surface from all of those rocks and stuff being in a molten state as Earth is forming. But the thing that I find I always have to remind myself of, and like my students especially do not have the correct conception of this, is that the mantle is not magma. It's not liquid rock. It's totally solid. It's thousands of degrees. It's way higher than the melting temperature of those rocks, but there's so much pressure that it doesn't flow like lava or magma or anything like that. So most of that water is not going to migrate up to the surface. It's going to be trapped in there just because the rate at which the mantle convects and moves is actually extremely, extremely slow.
So can you give any like scientific example, any other like, I don't know, like natural occurrence where there's even hundreds or thousands of gallons of water being trapped under the earth in any way, right? So because
What is
basically,
aquifers?
because basically you're like describing something that you've never observed. You're
Right.
theorizing that, the mantle somehow covered, quintillions of gallons of water into these giant basins, how they closed off, why they're so spread out. I've never even heard any theories for this. I do know that the largest one is called the Great Artesian Basin, somewhere in Australia. So I do know
Never
that's
heard of
one
it.
of the largest ones that exists. So can you give any examples of where this has been seen naturally occurring?
I
Even
can't in
on
the
so-called other
mantle, but we
planets,
know that there's.
anything?
Oh, sorry. I can't for the mantle, not exactly, but we know that there are aquifers, like the Ogallala aquifer, which is basically the whole middle of the United States. Some of the deepest parts of it are in Nebraska, right, where Glowman is because of the sandy soils. It drains really efficiently there. So, I mean, there's that's granted that's not the mantle, but that is subsurface water, and it goes very, very, very deep. It's hundreds and hundreds of meters into the into the earth, and it's in solid rock. It's not like these are caves with rock in them. That's another thing. That I think that's what people think groundwater is, but no, it's literally water in between the sediment grains of solid rock in most cases. Now, as far as like where do our ideas of water being in the mantle come from, I think it might be from seismic data, but I'm actually not 100% sure. But you know, that's I'm not a geologist, but I I don't have a super skeptical view on everything they say. But that's just I don't know. That's the only way to
Yeah, no, that's
exist. I
that's
feel like.
fair. Yeah, no, I hear that, man. That's always why I like joining. I think you get fair responses. Yeah, I mean, I've like really studied it, and I haven't seen any type of a model for how they say, they so-called became trapped. And you actually make a really great point too, about how the water really like exists in between minerals of the earth. However, there do exist basins, right, which are trapped. I remember, I want to say probably 6 years ago, I read an article about how China, they discovered underwater basins that had like hundreds of pounds per square inch of pressure. So there definitely are both, right? So that is a great point, but there also do exist trapped water basins which contain massive amounts of pressure per square inch. So I mean, I guess this, I mean, I'm not sure how you or anyone will take this, but so if there's not like really a scientific model that can explain how these things could form naturally, what's the difference between saying God did it?
Well, the evidence that would suggest it would be the main thing. I mean, the different isotopic ratios, things like that. You can look at rocks that rocks that like contain certain minerals that only form in the presence of water. I mean, literally going into the tails of comets and seeing like, hey, there is water here, right? In the same ratios that we see on Earth. It's all just more so adding together, right? Because science is more of it's deductive. We try to see what it's impossible to be first, right? Because there's an infinite number of hypotheses.
Yeah, well, I'm honestly, I'm not sure what an isotopic ratio has to do with it. I'm more trying to address merely a model that it can explain how it's possible, right? So I'm not saying that, hey, water doesn't evaporate, water doesn't seep into the ground, right? Some of this water isn't collected in areas. I'm not denying any of that. What I'm saying is, how do you go from that to then saying, hey, this, underwater basin that's over 1 million cubic square miles at 200 pounds per square inch of pressure formed under this same way? Because I don't think the evidence points to that at all. And that's why when you study these things, they don't say that was how it happened. They actually don't give an explanation. There really isn't one.
Well,
It's
I'm
just
not sure what
assumed.
the basin is supposed to be an argument for. So all I was saying was like with respect to where did the water on Earth come from? We know that asteroids and meteors and comets have a lot of water in them, and those are the things that we're pretty sure form planets like ours. So you just scale them up to the size of a planet like Earth, and you get enough. Like you take the tiny amount of water that's in an asteroid and the relatively tiny asteroid and multiply it and everything in it up to the size of planet Earth, and that tiny amount of water becomes as much water as Earth has, or
Yeah,
perhaps
so
more, or
I hear
perhaps
that. I
less.
hear that. And I'm sorry to cut you off here, but man, what you just did was invent something. You invented an idea, all right, a
Based on
scenario.
evidence.
That's not scientific evidence, right?
But it's based
And
on evidence.
yeah, well, I mean, there's a few things that could be said. I mean, for one, all the comets that so-called enter the Earth's atmosphere, they burn up. The ones that we're talking about are, 500 trillion tons in weight and size are things based on inference, a bazillion miles away, right? Where is the comet? I mean, why aren't they still entering the Earth's atmosphere, right? You're just assuming something happened in the past, right?
Yeah, well, that's the only thing we can do about the past.
Okay, well, that's fair. That's actually a fair answer to me. It's just sort of times when I mean, you'll get hit with, oh, you're making a God of the gaps argument when, I mean, quite frankly, it's very similar to saying, hey, God used a scientific process that we can't observe in real time to do X or Y. And then someone saying, oh, well, some other unforeseen force, caused X or Y to happen in the past. Like they're both based on inference, right?
Well, I think the difference is one is merely a claim and nothing else, and the other, it's a claim, but a claim that includes like a process, right? Like I'm telling you, like it is just a claim, but I'm telling you how we think it would have happened. But claiming that God did it is just a claim that God did it, not how or anything like that.
Yeah, so I actually that's fair. Probably more so in this example than others. I do think that there are examples, however, that are based on inference, but the same type of scientific inference nonetheless. So yeah, probably not as applicable for this one because again, there's not really a good explanation one way or the other. But in many other cases, I find it is more clear cut, right? I mean, there's many ways to choose a data set and derive an inference that's reasonable, right? And so again, I'm not denying that water evaporates, it seeps into the ground, that this may even build up pressure in different places. But using that as the explanation for some of these other phenomena, again, not even any evolutionists, not any scientific organizations I can find even make that claim, right? Really, as far as you go, it's exactly pretty much everything you've already said. Which, by the way, kudos to you because most people don't even know that. So again, I respect that. I just feel like there's still a level of inference that's pushed in either case. So I think the water on the Earth's surface and especially under the crust is pretty hard for the evolutionary theory to explain.
I mean, I don't see how evolution ties into that whatsoever, unless we're talking about planetary evolution.
Yeah, that would be correct.
But I mean, there's also other stuff that we have to keep in mind too. For example, when we believe these impacts would have been happening, we also wouldn't have really had much of an atmosphere, right? The reason stuff burns up now is because we do have a pretty thick atmosphere to protect us. But there's evidence to suggest that we wouldn't have had that kind of atmosphere on our planet when it was first forming. I mean, we see that with planets in general.
Yeah, so I do hear that argument, but again, I still feel like that's based off of inferences that have no scientific evidence to back them up. I mean, for example, we observe the atmosphere decreasing today. We don't see it building up. I mean, this is why we hear about the ozone layer decreasing, right? And faulting and how we see that affect the environment. So I mean, we want to put a start date, sure. I mean, you have to put it somewhere, but there isn't any evidence to actually support how that could even happen. Is the point?
I mean,
It's not like saying that, for example, that the atmosphere started at X date and has been decreasing since is based on the way we observe it today, right? It's the way we observe it today, right? And again, that's not like that's that unnecessary, right? It's a scientific inference, but it's still jumping to conclusions. You're still inventing ideas and theories, right? It's not backed by the scientific evidence. Well, the scientific evidence suggests that, hey, there's water pressure built up under the crust. How did it get there? There's not a scientific explanation for that.
I don't know what you mean there, like for how it's underneath the surface?
Not just underneath the surface, and not even in the same way that Peterson talked about how technically most of that water exists like submerged between minerals, but more so underwater basins, for example, those ones discovered in China. And technically they're all over the earth as well, and including the largest one that I mentioned in Australia, right? There's no good explanation for how the mantle, I mean, again, he points out it's not molten, which is true, but it was still formed from molten, right? How did a molten rock encase quintillions of gallons of water, right? Or, that's exaggerating. Well, I'll be realistic. Okay, so a million square miles of water, right? Which I don't know the exact amount that it is, probably like a fraction of that, right? Like 5 or 6 quintillion, something like that. But that's more realistic. There's not a way to explain that using the scientific method. And if there is, it can't be replicated, is the point.
But it kind of goes back to the aquifers thing. It's not like a big open cavern just with like water on the bottom sitting there. It's going to be trapped within the layers. It's going to sure be in an environment with a lot of pressure, but it's not like pressure like analogous to inside of a can.
It didn't work that time.
I hear you. I hear that. I'm not, and maybe I'm coming off a little wrong. I'm not saying that it's necessarily unreasonable. In the very least, I'm just trying to see if we can acknowledge that it's based on something you can't replicate in the present. right?
I don't know
All
about
the
that.
different types of ways we can date the
Look, I
past
made a
are based
Minecraft
on
world
ways
once,
we
and there
test
was
in the
tons of
present.
water below ground. Okay, so I don't know what you're talking about.
Well, we all,
And one day I'll get good at Unreal Engine. Okay.
but we also have like plate tectonics and stuff, right? Like faulting, and the Earth's crust is literally moving.
Yeah,
That can
yeah.
also create pockets to where water could potentially be trapped.
How? Where? When's that been done?
What do you mean? That's just how we have. I mean, I can try to find a specific example, but it's just faulting, right? Tectonic plates move. That's something we see all the time. I mean,
Yeah, no, I'm not
seismologists and
denying
stuff like
the
that.
the faulting. They're moving, right? At a like it's they say about the same pace that your nails grow, right? Now, I'm not denying that. I'm saying where do we see them trap billions of gallons of water and with a pressure? Oh, we got a timeout.
I said I was gonna go like 20 minutes ago. I really need to go.
Yeah, you
Okay,
did. I jumped on at the
no
last
worries.
second. Hey, I appreciate it.
You're welcome.